Hi, in this video I'll be talking about how to find the area of a sector. So first of all, what's a sector? Okay, so here assuming that we have a slice of pizza and I am taking this part of the pizza out. This is this shape that I have here. Let me highlight it. This shape is called a sector. Okay, so it is sort of like a section of your circle. Okay, so this is a sector. All right. Now, if let's say today this, let's make it easy. Let's say today I am taking out 90 degrees. Okay, 90 degrees. The sector I'm taking out is 90 degrees. Now, how much? And let's say today my radius is say 5. Let's say a proper pizza, 12-inch. So let's say that's around a 12-inch pizza. So the radius is going to be 6-inch, right? So how much area did I take out? Right. So 90 degrees, radius is 6. What's the area of the pizza that I got? Okay. Now, to find the area of the whole thing, of the whole pizza, the area of the whole is going to be pi r squared, right? My r is going to be 6. So that'll be 36 pi. All right, cool. But right now, I don't have the entire 36 pi. I don't have the entire pizza. I only have 90 degrees of it. So, which means I have 1/4 of the whole pizza. But how did I get the 1/4 from? Using the angles, it would be 90 degrees over 360. Because one circle is 360. Right now I have 90. So 90 over 360 times the entire whole pizza, which is 360 pi. That gives me, so this is 1/4. So 1/4 times 36 pi, I get 9 pi. 9 pi, say inch squared. So that's how much pizza that I have if I take 90 degrees out. That might sound weird, but this is just an example. Okay? Now, similarly, if today we have still a pizza, and let's say I take out theta, and today I have this area that I want to find, and the angle that I'm taking out is theta. Okay? And let's try to talk about this in radian then. So, as we have seen here, 90 is the angle that I have. The 360 is the entire angle for the circle. Right? So this is the angle that I have, the angle that we have. Over the full circle, right? And then multiply, and then what do we do? So we have the angle that I have divided by the full circle, and then we multiply the 36 pi. What's the 36 pi? The 36 pi is the area of the whole thing. So I'm going to multiply the area of the whole thing. Right? So this is kind of the formula the approach that we did. So in this case, now we're talking about radian. Okay, we're talking about radian now. The angle that I have here, obviously, is going to be theta. What's the angle of a full circle? The angle of a full circle in radian, right? Angle of a full circle in radian, that would be 2 pi, right? Angle of a full circle is 2 pi. And what's the area? Area is 2 pi r. Oh, sorry, my bad. Area is pi r squared. Pi r squared. So this is going to give me the area of a sector. Right? The area where I have this theta as the angle. And you can see that, interestingly, a bunch of stuff can be cancelled out. The pi goes away. I will have theta over 2 times the r squared. You can bring the r to the numerator. So I have theta r squared over 2. This is the standard formula to find area of a sector if your angle of the angle of a theta is measured in radian. Okay. However, if your angle is measured in degrees, then the approach would be here, similar to that. But ultimately, what we are doing is we're using this logic here. We're using the angles to represent how much of the whole, right? How much of the whole pizza do we have? So the angle that we have on the numerator, the angle of the full circle in the denominator, and that will give us a ratio or a portion, the proportion where I know how much of the original that we are interested in, or we highlighted, shaded. Okay, so let's try a few examples. Feel free to rewind this video to try to understand how did this area of a sector formula come about. Okay, feel free to rewind and figure that out, just to understand it. I'm gonna go over one example with you guys. Let's take a look. Okay, so in this question, this example, they want us to find the red area, right? The shaded area, the red area. Okay, so pause the video. Think about how we can extract the red area out. All right, welcome back. Now, if you think about it, my red area kind of looks like that. Isn't that equal to the sector minus the triangle, right? The area of the red part is equal to the sector and take out the triangle. Does that make sense? And that's what we're going to do. So let's find the area of the sector first. And area of a sector, this is going to be 1.48 radian. Nice, because we can just apply the formula right away. So this is going to be 5. Sorry, this is 5. And my angle is 1.48. And this is, for this triangle, this is 5, and this is 1.48. All right, so let's try to find the area of the sector. So area of a sector is equal to half times r. In this case, my r is 5. My theta is equal to 1.48. Right? Oh, I missed the r squared. Minus, now the area of a triangle. Area of a triangle, we talked about this in class, and I also show you guys a video on the class website. It would be, so since this is 5, the radius here is also going to be 5. I have 2 sides and the angle between them. So I can apply the formula as well. 5 times 5 times 1.48. Actually, I made a mistake there. Let me write this better. This will be minus half times 5 times 5 times sine, right? Sine of the 1.48. You're going to use a calculator, but make sure you change your degree, your angle measure, to radian, okay? So on the calculator setting, take your calculator out, make sure you change the angle from degree to radian. And if you put your calculator, if you type this in your calculator, your answer is going to be approximately 5.83. There's no units, so maybe just say unit squared. This is the area of this kind of a D-looking shape. All right, that's it. Hope you guys find this video helpful. If you have more questions, please bring them to class. See ya.